Hello everyone, a very good evening to all. Myself, Vivekananda Nayak. I am a PhD research scholar in the Department of Energy Science and Engineering, IIT Delhi. So, I welcome you all once again for this introduction session on the course Experimental Physics 1 with course code NOC 25 PH51. We wrote this July 2025 session by NPTEL. So today basically this is a since we have already completed 12 sessions and we have discussed problems related to the course course contents. So today we will solve a few more problems that will cover the whole um, concept that has been taught in this course. So let's start with the problems that we are going to solve. So this is the problem number one. So problem number one says, what is the uh, reason of using rosin flux during soldering? We know when we solder that we want to connect to metal connections for electrical equipments and all, we often do soldering, and during the process of soldering we use rosin flux. So the question says, what is the reason of using the rosin flux? Options are: option A, rosin flux is used to keep metal from oxidizing when heated. B, rosin flux helps to heat the body quickly. C, rosin flux helps to melt soldering wire quickly. And option D, all of the above options are true. Now we know, in order to what is soldering? Soldering means connecting to metal surface. So if there are impurities on any metal surface, then there will not be any proper connection between the metal surface. So the main purpose of flux is to clean the metal surface. So the main purpose of the flux is to clean the metal surface, and it cleans the metal surface by removing any oxides and the impurities that might have been present in that metal surface. Because when any surface is exposed to air due to the presence of oxygen in the air, then get oxides, and then basically oxide is a form of like junk that we see in iron. So it is basically due to formation of oxides over iron, which results in improper connection. So flux is used to keep the metal from oxiding when heated. So option A will be the correct option. So oxides, when oxides are formed when the metal is exposed to air, and they prevent the formation of good joints. So in order to overcome those phenomena, we use rosin flux. So the correct option is rosin flux is used to keep metal surface from used to keep metal surface free from oxiding. So when heated, then option B, rosin flux helps to heat the body quickly. No, it's not correct. And then rosin flux helps to melt soldering wire quickly. That's also not correct. So the correct option is option A. That is it is used to keep the metal free from oxidizing. Now let's move to question number 2. So question number 2 says, the length and breadth of a rectangular sheet are 6.2 centimeter and 0.152 centimeter respectively. The area of the sheet in appropriate significant figure is. Options are: option A 0.94 centimeter square, option B 0.623 centimeter square, option C 0.9424 centimeter square, or option D none of these. So this problem is based on the concept of significant figures. So here we have two values. One is length and another is breadth. So length, length is equal to 6.2 centimeter and breadth is equal to 0.152 centimeters. So what will be the area? So area, we know for a rectangle, area will be length into breadth. So when you multiply 6.2 into 0.152, it will give you 0.9424 centimeter square. But the question says in appropriate significant figure. What is appropriate significant figure? Appropriate significant figure. So we know according to the concept, according to the rules of significant figure, in multiplication or division, the results will be having the least significant figure out of the available values or available number of significant figure in the given value. So for 6.2 it has two significant figures, for 0.152 it has three significant figures. So minimum is 2 is minimum. So in order to have correct in order to have appropriate significant figure, the result should have minimum significant figure, that is 2 significant figure. So 0.9424, when we reduced it to significant figure, which is 2, it will be 0.94. So the correct answer is 0.94 centimeter square. So option A is the correct option. Now question 3. So question 3 says a student measured the length of a rod and wrote it as 3.50 centimeter. Which instrument did he use to measure it? Options are option A, meter scale; option B, a vernier caliper where the 10 divisions in vernier scale matches with 9 divisions in main scale and main scale has 10 division in 1 centimeter; option C, a skew gauge having 100 divisions in circular scale and pitch as 1 millimeter, and a screw gauge having 50 divisions in circular scale and pitch as 1 millimeter. So what was the measurement result? So the value of measurement was 3.50 centimeters. So what is the least count of the instrument that it has been used to measure? So it is 0.01 centimeter. So this 0.01 centimeter is the least count. That's why we are getting the value up to 2 places after the decimal point. So the instrument that has been used, it has the least count of 0.01 centimeter or 0.1 millimeter. So the least count of 0.1 millimeter. Now let's consider about the least count of the device. So meter scale, the least count of meter scale is 1 mm. So again it is not correct. So if it is 1 mm, then it will be 3.5 centimeter only, not 3.50. So in the second case, it is vernier caliper who has 10 division in vernier scale matches with 9 division in main scale and main scale has 10 division. So we know in case of so here it will be 1 by 10. So it will be 0.1 mm least count for vernier scale. Now for screw gauge, 100 division and so pitch as 1 mm, so it will 1 by 100, that is 0.01 mm, and for option D, 50 division, it will be 1 by 50, that is 0.02 mm. So the least count of the device we need is 0.1 mm. So the correct option is option B, 0.1 mm, because the vernier caliper which has 10 divisions in vernier scale which matches with 9 division in main scale and the main scale has 10 division in 1 centimeter. So this is, so 10 division in 1 centimeter means 1 division is 1 millimeter and it has 10 division equal to 9 division, so it is 1 by 10, that is 0.1 millimeter is the least count of the vernier caliper. So the student has used the vernier caliper to measure the length of a rod. Now question number 4, an ammeter is connected in dash with the circuit element whose current we wish to measure. So we know in case of an electrical circuit, current remains same in series, voltage remains same in parallel connection. So suppose this is a connection, so since it is a series connection, so same current will flow, and in case of parallel connection, so since these three are parallel connections, so across all these same voltage V will appear. So since ammeter is used to measure current, so it is connected in series, because along a series circuit the current remains the same. So in order to measure the current accurately, ammeter is always connected in series. Now question number 5, a galvanometer in series with a high resistance is called. So this is if you remember the initial session that we have already discussed, how to convert galvanometer into an ammeter, how to convert galvanometer into voltmeter. So when you connect a high resistance in series, it is converted into, so galvanometer plus high resistance in series, it gets converted into voltmeter, because voltmeter is a high resistance galvanometer. So only, so since voltmeter is a high resistance galvanometer, so it can measure the voltage accurately. Similarly, galvanometer plus small resistance in parallel, it is called as, so ammeter. So ammeter is a low resistance galvanometer. So voltmeter is a high resistance galvanometer. Ammeter is a low resistance galvanometer. So galvanometer in series with a high resistance is called as a voltmeter. Now question number 6. So question number 6 says the resistance of an ideal voltmeter is. So the resistance of an ideal voltmeter is, options are option A low, option B infinite, option C 0, and option D high. Now what is the use of voltmeter? So voltmeter is used to measure voltage, and voltmeter is connected in parallel, and it is connected in parallel. So in order to accurately measure the in order to accurately measure the value of voltage when it is connected, suppose this is a circuit and we want to measure the voltage. So if, so this is the case. Now voltage drop, suppose here the voltage drop is V, and in order to measure that voltage drop, we have connected the voltmeter here. So since the voltmeter is connected, so since the voltmeter is connected in parallel, if it has low resistance, then if more current will pass through this branch, and the accurate value of the voltage that can be measured. So in general, since voltmeter is used to measure accurately the value of voltage, so very less current should pass through voltmeter, so that majority current will pass through the actual branch, and we can measure the voltage accurately. So the for an ideal voltmeter, its resistance is infinite. So infinite means, so suppose current I is flowing, so all current I will flow through this, and current 0 will flow through this. So it will not perturb the circuit, and it can measure the value accurately. So that's why voltmeter has very high resistance, and for ideal voltmeter the resistance is infinite. I hope this is clear. Now we move to question number 5. Sorry, question number 7. Question number 7 says a galvanometer of resistance R is shunted by a very small resistance S, the resistance of the resulting ammeter. So we know when a galvanometer is connected to a shunt resistance, that is a small resistance in parallel. It is called as shunted means connected in parallel. So what is the, so this as a whole, this is called as a ammeter. So what will be the resistance of this ammeter R prime? So it will be, so R prime, we know for parallel connection it is 1 by R plus 1 by S. That implies 1 by R prime is R plus S by RS. That implies R prime is RS divided by R plus S. So the correct answer is RS divided by R plus S. So the resulting ammeter will be having the resistance RS divided by R plus S. I hope this is clear to you. Now I move to question number 8. So question number 8, uh, it says a CRO is used to measure. So we know, we have already discussed a few problems regarding the CRO, and the lectures that were part of this course. They have already, it has been already explained quite well how the CRO is working, how it measures different parameters. So CRO is used to measure voltage, frequency, and phase. So the correct answer is all of the above. So this one is the correct answer. Now question number 9. Question number 9 says the material used to coat inside the face of cathode ray tube. So CRT is cathode ray tube. So the material used to coat inside the face of cathode ray tube is, options are option A carbon, option B sulfur, option C silicon, and option D phosphorus. So we know, what is a cathode ray tube. So cathode ray tube, one of the component of cathode ray tube is an electron gun, and then electron, after electron comes out, then those electron beams are focused by applying voltage across the electrode. Then in order to deflect the electron beam, because when the electron beam strikes at the um, face of the cathode tube, then the point appears on the screen. So in order to deflect the point along x direction and y direction, we have x deflecting plates and y deflecting plates, and depending upon the biasing event to those plates, and depending upon the energy of the electron guns, the position of the point on the screen, that can be determined. So uh, and the screen should be a phosphorescent screen, and so the screen, in order to show the results, it is coated with phosphorus. Question number 10. So question number 10 says time intervals measured with a stopwatch typically have an uncertainty of about 0.2 second due to human reaction time at the start and stop moments. What is the percentage uncertainty of a hand timed measurement of 5 seconds? So here you see, so uncertainty in measuring time, uncertainty in time measurement is 0.2 second, that is delta t. So both at start and stop we have delta t uncertainty. So for a time measurement value of 5 seconds, at start delta t uncertainty, and at stop delta t uncertainty is also present. So what is the total uncertainty? So delta t total is 2 delta t, that is 0.2 plus 0.2, 0.4 seconds. So what is the percentage uncertainty? We know percentage uncertainty will be delta t by t into 100%, that implies delta t is 0.4, t is 5 into 100%. So 0.4 divided by 5 is 8%. So the correct answer is 8%. So here the option, I think this will be, suppose option B will be 8%. So the correct answer will be 8% because it mentioned human reaction time at the start and stop moments. So at the start, when the measurement started, there must be uncertainty of 0.2. Then at the stop time, there must be uncertainty of 0.2. So total uncertainty is 0.4 in the measurement of 5 seconds. So the percentage uncertainty is 8% in the measurement if we have 0.2 second uncertainty. Now question number 11. So before solving this question number 11, we will take a few minutes break and then we will again start solving the remaining 10 problems and we will complete that. So let's discuss the remaining questions. So question number 11 says elasticity is the property of the solid which is caused by, options are option A, the applied deforming force, option B, gravitational force, option C, nuclear force, option D, intermolecular force. We know the elasticity is the property of solid which is caused by intermolecular force. So option D is the correct option. Now we move to question number 12. Question number 12 says shape of the surface of a liquid in a tube is convex if cohesive forces between the molecules of a liquid are much stronger than the adhesive force. Option B, cohesive force between the molecules of liquid is much weaker than the adhesive force. The cohesive force are absent. And option D, the cohesive force are as strong as the adhesive force. Now, the shape of the surface of a liquid in a tube. Suppose this is a tube. The shape of the surface is convex. Convex means so this is the convex face. So suppose this is the liquid. So cohesive force between the molecules of the liquid are much stronger than the adhesive force. The cohesive force between the molecule of the liquid is much weaker than the adhesive force. So since the cohesive force between the molecules of liquid are much stronger than the adhesive force, that's why the surface will be a convex surface. So option A will be the correct option. So if it is much weaker, then it will be concave. Now question number 13. Question number 13 says surface tension of the liquid depends on, options are option A, the area of the surface of liquid, option B, the length of the line considered, option C, the area of the surface and length of the line considered, and option D, the nature of the liquid. So we know surface tension. What is surface tension? So surface tension is the property of a liquid due to which it needs to have a minimum surface area, because minimum surface area means maximum stability. So, and due to the property of surface tension, sometimes the liquid can uh, what we can say. So due to the property of surface liquid, can carry substances which are even heavier than the density of the liquid. For example, you must have seen bats, sorry, small flies, they are standing on the surface. So that, so when they sit on the surface, then at the point of contact some spherical surface is cleared. This is due to the surface tension and and we know the surface tension is a property of the liquid, so it is the nature of the liquid. So the correct option will be option D. Now question number 14. So question number 14 says work done by a torque in pure rotating a body about an axis is equal to the change in, options are option A, rotational kinetic energy of the body, option B, momentum of the body, option C, translation kinetic energy of the body, and option D, all are true. So work done by a torque in rotating a body about an axis. So work done by a torque in rotating a body. So what will be the work done by a torque in rotating a body? So it will be, so work done will be tau dot theta. So if you integrate, it will be theta 1 to theta 2 tau, which is also a function of theta, and d theta. So this will be equal to half I omega square. So this half I omega square, this is equal to rotational kinetic energy of the body. So the work done by the torque in rotating a body about an axis is equal to the rotational kinetic energy of the body. Question number 15. So it says a glass rod is heated to a high temperature and then allowed to cool. If it cracks, a probable reason for this is the following property of glass: low heat capacity, option B high thermal conductivity, option C high specific heat, and option D low thermal conductivity. So a glass rod is heated to a high temperature and then it is allowed to cool. If it cracks, then what is the probable region? So it cracks means it can't, so it cracks means it can't cool. That means it cannot radiate or conduct heat to the surrounding. So it has low thermal conductivity. So the correct option is option D. It has low thermal conductivity. Now question number 16. It says viscosity is closely similar to. So viscosity is defined as the property of the liquid due to which we know liquid flows through different layers. That's why when we draw, so let's, so options are option A density, option B velocity, option C friction, and option D surface tension. So we know when a liquid flows, so we draw it like this. So liquid flows to different layers, and when the liquid layers are perturbed, so the force which acts against the perturbation, that is the force which prevents the change between the two layers, or the frictional force between the two layers, it is called as the property of viscosity. So the viscosity, it can be closely related to the, because it acts opposite to the relative motion of the two liquid layers. So means it is closely related to the friction, because the job of the friction is also same. It acts opposite to the relative motion. Now question number 17. So it says the amplitude of damped harmonic oscillator. So options are option A remains constant, option B decreases exponentially, option C suddenly becomes zero without any oscillation, option D increases exponentially. So we know the so there are different type of oscillations: simple harmonic oscillation, forced oscillation, damped oscillation. So it is a case of damped harmonic oscillator. So we know in case of a damped harmonic oscillator, its amplitude decreases exponentially. So suppose this is the amplitude, it will decrease exponentially. We know this is the value of amplitude. So after each oscillation, its amplitude goes on decreasing. So the correct option will be option B, decreases exponentially. So if it is remains constant, then it is a free oscillation. So remains constant means this is a free oscillation, and suddenly becomes zero means, so it will fall like this. So this is the, so it will without any oscillation, since it's not completing a oscillation, so suddenly becomes fall and then increases exponentially. So the condition of in so when increases exponentially, how it becomes, so it will be like this. So it increases exponentially. Basically, this type of oscillation is generally found in case of resonance. So in case of resonance, it, since it gains continuous energy from a point, its amplitude goes on increasing exponentially. So the correct option is option B. For an damped harmonic oscillator, its amplitude decreases exponentially. Now question number 18. So question number 18 says, in a RC circuit, in case of varying current, what is the quantity RC is called? Option A, time constant. Option B, voltage constant. Option C, potential difference. And option D, charge. So we know in case of an RC circuit, the capacitor it can store energy, so it charges and discharges. So in case of a time varying current, the capacitor charges exponential. So we had already discussed. So Q is Q0 1 minus e to the power minus T by RC. So here RC is called as time constant, and RC is RC is defined as the RC is defined as the amount of time required so that the charge. So in case of charging, it charges to 1 by e times of the initial charge during the discharging process. So the value of RC is called as time constant. In the last interaction session, we were solving this type of problems related to the concept of RC circuit. Question number 19. So question number 19 says, in an LCR circuit, it contains inductor, its value is L equals to 8 Henry, capacitor C equals to 0.5 microfarad, and resistor equal to 100 ohm, and both and all are connected in series. So this is an inductor, this is a capacitor, and this is a resistor. They are connected in series. What is the resonant angular frequency will be? Options are option A 600 radians per second, option B 500 radians per second, option C 400 radians per second, option D 300 radians per second. So I'll give you a few minutes to solve this question and then we will discuss. So this is based on the concept of series LCR circuit and what is the condition of resonance. So we know during the condition of resonance, XL equals to XC, and you know XL is equals to omega L and XC is 1 by omega C. That implies omega square is 1 by LC, or omega is 1 by root over of LC. So it's 1 by 8 into 0.5 into, so so L is 8 Henry, C is 0.5 microfarad, and R is 100 ohm. So this will be 1 by 8 into 5 by 10 into 10 to the power minus 6. So uh, it will be 10 to the power minus 6 means minus 3. So 10 to the power 3 divided by root over 4. So it is 1000 by 2. So 500 radians per second. So the correct answer is option B, 500 radians per second. Now question number 20. So question number 20 says mutual inductance between a pair of coil is 5 Henry. A circuit of 10 ampere current flowing through one coil is cut off in 0.5 second. The EMF in the other coil, options are option A 5 volt, option B 50 volt, option C 100 volt, and option D 150 volt. So these are the four options. This is based on the concept of mutual inductance. And we will solve it in a few minutes. So we know due to the property of mutual inductance, the uh, rate of change of magnetic flux or the produces EMF in the produce in the change in flux linked with one coil produces the EMF in another coil. So we know EMF it is, so we know in case of mutual inductance phi is given as M into I and EMF is given as d phi by dt, that implies d by dt of mi m di by dt. So EMF is m into di by dt. So m is 5 and current changes from 10 to 0 in time period 0.5 seconds. So it is 5 into 10 divided by 0.5, that implies so 0.5 so it is 100 volt. So the correct option is option C, 100 volt. So when the current in one changes from 10 ampere to 0, so current flowing through one coil is cut off means I2 is 0. So this is I1 10 and in 0.5 second is the time period. So the EMF calculated EMF is 100 volt. So with this we come to the end of today's interaction session. So this concludes the interaction session that I was conducting for this experimental physics 1 course this semester. I hope the problems that I have solved and the concept you have covered in the week's lectures that will help you in preparing your exams and to get good marks in your exams also. So with this, uh, we come to the end of this interaction session on experimental physics 1 course. That's it from my side, and I wish you all the best if you are appearing for the exam at the end of the course. Thank you so much.